Alright guys, so this video is just going to cover our Algebra 2 test prep. This is intended just for my students, not really intended for anybody else. We're going to cover the topics that are going to be on your test come Monday. Alright, so the following topics are going to be on your test on Monday. Radicals, factoring difference of perfect squares, factoring perfect square trinomials, and then factoring by grouping. Just these 4 topics, and we're going to cover them all kind of briefly. This review is going to go kind of quickly. Feel free to slow down the video, half speed, whatever you need to do. Feel free to pause and rewind as necessary. So start off with just radicals. Our properties of radicals that we have to deal with. First off, you have to be able to simplify a radical. Okay? Simplifying a radical is a big deal. So I gave you on the board square root of 200 as your prime example for simplifying a radical. Just remember, you have to factor this down. And there are 2 ways to do it. So I'm going to actually write it in 2 different ways. You could absolutely deal with this and bring it down to all its prime factors, or you can simplify this and realize that there are earlier pairs that you can deal with. So the quickest way would be to realize that this is 2 times 100, 100 being a perfect square. Because it's a perfect square, you can go ahead and pull out for each pair, pull out one of that number, and then 10 root 2. On the other hand, if you were dealing with this over here and we didn't realize that this had a perfect square in it for us to simplify, it doesn't matter if you don't realize that there's this pair of 10s. You could pick any 2 numbers you want. This could easily have been 20 and 10. One very obvious example. And then let's just go all the way down to our prime factors. 2 and 10, 2 and 5, and then 2 and 5 again. You would have noticed that, hey, I have a pair of 2s and I have a pair of 5s. But unfortunately, there's still this random 2 left up here. It's perfectly okay. So for every pair, we pull out one of that number. Every pair, we pull out one of that number. Once we're out of pairs, we're going to go ahead and put our radical sign back and throw in whatever was left over. So here we had a 2 that's left over. Go ahead and put it back underneath the radical. 2 times 5 is 10 root 2. You'll notice these 2 answers are exactly the same, because they are exactly the same process. It's just that this person would have noticed that there's a pair of 10s and this person did not notice that there was a pair of 10s. No big deal. Makes no difference. I do not care whether or not you have to take the long way or the short way. Both answers are correct. Alright? And you should be able to do this with any number, like square root of 300, square root of 165. It really doesn't matter what number. If for whatever reason on the test you get an example that cannot be factored, you can just leave it as square root of 200. Okay, so if I ever give you square root of a prime number, so square root of, I don't know, let's say 7. 7 doesn't break down into anything that can pair up, so your answer at the end would just be square root of 7. Alright, so that's simplifying radicals. Hopefully you remember. You just have to break down in this factor tree and find your factor pairs. Alright, cool. So that's simplifying radicals. Let's go ahead and talk about adding and subtracting radicals. So adding and subtracting radicals is going to work a little bit differently. Adding and subtracting radicals, you just have to remember that they work a lot like terms. So in any problem where I have a bunch of radicals, let's say, I don't know, 5 root 8 minus 3 root 2 plus 4 root 8 minus, I don't know, 5 root 5. This problem is fairly simple. You'll notice that these radicals are the same, and then you've got a root 2 and a root 5. Okay, and the root 5 will actually do an orange. So regardless, you'll notice that we have 3 different radicals here. What you have to do is think of this as like terms. So in like terms, we can only add or subtract the coefficients with similar variables. This is going to work the same way. You can only add or subtract coefficients with the same radicals. So you'll notice root 8 and root 8, we would be able to simplify those 2. But root 2 is not the same as root 8, root 5 is not the same as root 8 or root 2, so we can't combine anything with root 5 and root 2. They're going to stay the same. If it makes it any easier, you can always rewrite this problem with variables. Let's call root 8 x. So this would be like 5x minus, and let's call root 2 y. 3y. Again, root 8 we said we're going to call x, so let's go ahead and rewrite that. And then 5 root 5, let's call that z. You can call them whatever letters you want, but you'll notice here that if we do our process of combining like terms, the only like terms we'd be able to combine are here and here. 5 plus 4, which will give you 9x. So, on the same token, we'd look back at our radicals and we say, okay, well here's 5 root 8, 4 root 8, let's go ahead and combine them. 5 root 8 plus 4 root 8 is 9 root 8, followed by technically just minus 3y, but our 3y was a root 2, so we're just going to write 3 root 2, because it does not have that root 8, so we wouldn't be able to do anything with it. And then at the end, we've got that 5 root 5. Okay? On your test, I'm more than likely going to give you a set of radicals that cannot be simplified, but just for future reference, and this part you can skip. If you're only preparing for this test, you can go ahead and skip this, but technically we can't leave this root 8 like this. We would have to simplify it. 4, 2, 2, 2, pull out a 2, and it would be 18 root 2. But again, don't stress that. That is not going to be on the test. I'm not going to include a problem like that on the test, so you don't have to worry about it. I just didn't want to leave an unfinished answer. Mathematicians are kind of retentive like that. Anyway, so that would technically be your final answer. But on your test, you only need to worry about getting here. Think of it as combining like terms and you'll be perfectly fine. Okay, let me go ahead and get all that on screen at once. Alright. So yes, feel free to make sure that you know how to do these first 3 things. Really, you just have to be able to combine like terms. Both have root 8s, so we can combine them both. That's a root 2, can't combine it. That's a root 5, can't combine it. Alright? And that's how we would handle adding and subtracting radicals. Alright, next with radicals on your test, there's going to be one more topic that we cover. That's going to be multiplying and dividing radicals, and I'm going to make one that looks very similar to this. You're going to get a problem with something like this. Let's see, the square root of 50 times 10, or square root of 10, sorry, over the square root of, let's go with, by 20. Okay? Something along these lines. What you have to remember is that you can actually combine all these square roots into one. So this is really like one big multiplication and division problem, right? One big square root, and then we're just going to multiply the things on top and divide by the thing on the bottom. From here on, we're just going to go ahead and simplify. So 50 times 10 is 500, all over 20. And then we keep simplifying, so 500 divided by 20 is just going to end up being 25. And then we know that the square root of 25 is just 5. Square root of 25 is just 5. So on your test, I'm expecting to see this. Again, there are going to be things that we do with this further in the future. Technically, this answer looks like this, but I want you to ignore that for purposes of the test. Alright, all I'm looking for is the square root of 25 to equal 5. That is all that's going to show up on your test for radicals. So again, in case you need to pause or rewind or whatever, go back. The first one was just simplifying a radical. The second one was combining radicals through addition and subtraction. Looks like that. And then the last thing that you'll have to do is multiplying and dividing radicals. Outside of that, we have factoring, and there are only going to be 3 types of factoring on this test. The first type of factoring that you're going to see is factoring by difference of perfect squares. And I told you guys during class that you actually can do all of these types of factoring with factoring by grouping if you'd like. But difference perfect squares. Okay, so I told you guys that you can actually do all of these with just factoring by grouping. And if you'd like to memorize just one method, that would be the one method you use. But with factoring difference of perfect squares, what you're looking for are a couple of qualifications. First off, are the first and second terms perfect squares? I'm going to shorten this a bit. And the second question is, are they separated by a minus sign. Okay, so as long as it fits these two conditions, we're all good. So let's go ahead and do an example problem that looks like that. Something like 16b squared minus, I don't know, 16. This one's going to work out kind of pretty. So first off, are the first and second terms perfect squares? So there should only be two terms in all of these difference of perfect squares terms. We'll take a look at them. 16 is a perfect square. B squared is a perfect square because it has an even exponent. And then 16 we just said was a perfect square. So we're good. So once that happens, as long as we fit these two conditions, we're all good, and we're just going to move on. So now we just have to do the square root of some values. So let's take the square root of 16 first. So the square root of 16. So we'll take the square root of both sides. Okay? Square root of 16 first is 4. And then the square root of b squared is b. And then again, you told me the square root of 16 was, or I'm sorry, I said the square root of 16 was 4. So we'll put it there. And then you're just going to write both of these things twice. Excellent. Throw some parentheses around them. And then your very last step is that you're going to write your signs in. They have to be plus or minus signs. This is how binomials look. And we're going to separate one with a plus, and we're going to separate the other one with a minus. It actually makes zero difference which order you put them in. This could have easily been minus and then plus over here. It really doesn't matter. That's completely up to you. This is going to work for every single difference of perfect squares. So again, ask yourself those two questions. As long as it fits, take the square root of both sides, write them twice, put parentheses around them, and then put a plus sign between one of them, minus sign between the other, and you are all set. That is how to handle a difference of perfect squares. Alright, you will have a couple of these on your test. I highly recommend you learn how to use them. And again, you can do this by factoring by grouping, but it would just be longer and a little unnecessary. So let's talk about factoring perfect square trinomials. Factoring perf square trinomials. Okay, so factoring perfect square trinomials, you have similar questions. First question: are the first and last terms perfect squares? So this one's worded a little differently because it's probably perfect square trinomials. Tri means 3, so they're going to have 3 terms as opposed to perfect squares. Sorry. So are the first and last terms perfect squares? So just A and just C. Don't worry about that middle term, that B, just yet. Okay. Second, does the square root of the last term times 2 equal B? As long as it fits these two conditions, you do have a perfect square trinomial, and we can factor it this way. Okay, so let's go ahead and get an example going on with this. Let's try something like so we'll go with b squared. I'm using a lot of b's today, I'm not really sure why. I'm sorry, that can be confusing. So let's not talk about that because we call this our b term. So let's go ahead and just use x squared, our typical variable. Okay, x squared plus 25 plus 10x. Okay, so here is our trinomial. Again, let's go ahead and take a look. The first and last terms perfect squares. So x squared is a perfect square because it has an even exponent. 25 is a perfect square because the square root of 25 is 5. Does the square root of the last term, so square root of the last term, square root of 25 is 5, times 2. 5 times 2 is 10. Does it equal b? It does. Alright, and since we have that, we're all good. This is a this is a perfect square trinomial, so we can go ahead and simplify it. What you're going to do, much like you did with difference of perfect squares, is you're going to square root the first term, square root the last term, and after we square root those, you'll get x and 5. You're going to write it twice, just like you did with the last one, put parentheses around them, but this time you're going to look for one extra thing. You have to look in the very middle, and you have to take a look at this middle number. If it is a positive, then these are both positive. If it's a negative, these are both negative. So here's a positive, here's a positive. Because that one's positive, both of these signs have to be positive. So you'll notice that the difference between difference of perfect squares is that over here we have different signs, and then over here we have the same sign. So it'll either be x plus, or x minus, something like that. Okay? So factoring perfect square trinomials has to have these two conditions met. Difference of perfect squares has to have the other ones. Hopefully you'll remember these. Again, you can use factoring by grouping to do this. Let's go ahead and talk about factoring by grouping. It'll be the last thing that's on this test. So factoring by grouping. You guys all received a handout on how this works. Factoring by grouping. I'm not going to write out all of the word terms for how to do it. It is in your handouts that you guys have. So factoring by grouping, it's also covered in several other videos on this channel, so if you absolutely need help, you can always find the specific video on factoring by grouping. But we can have any given problem. It really doesn't matter what it looks like as long as it's a factoring problem, and then we'll factor it by grouping. So let's go ahead and pick a problem, something that looks like, let's say, something like 8x squared minus 2x minus 3. Yeah. Okay. So if we're given this problem is, it looks a little different. It does not fit any of our conditions, so it doesn't fit these conditions. Their first and last term's perfect. We take a look at it. First term is an 8. Last term's a 3. Neither of those are perfect squares. Doesn't work. The same thing happens with difference of perfect squares. So it doesn't fit any of our other qualifications. So we have to factor this one by grouping. Let's go ahead and do that real quickly. Your first step is to take your A term, your coefficient from A, and your coefficient from C, and multiply them together. Multiply. Okay? So let's multiply them. 8 times negative 3 gives you a negative 24. After you do that, you have to factor your answer from multiplying A and C. So let's factor negative 24, and you have to get the factors that add up to negative 2. If you don't immediately recognize which factors they are, then we're going to go ahead and do this a long way. So I'm going to make it so that our factors are going to be at the bottom. So you're just going to name whatever factors come to mind. And maybe you're like, well, I know this is 1 and 24. This is a negative, so this one has to be negative. Or this one has to be negative. So I know both combos work. Okay. So 1 and 24, 2 and 12 would work. Remember, one has to be positive, one has to be negative at all times. 3 and 8 would work. Again, one positive, one negative at all times. And then you can keep going, but the next one's going to be what we need. So you would need also 4 and 6. Again, one positive and one negative. So remember what we said is that we have to get the factors that add up to our negative 2. So we just need to add these together until we get negative 2. That's the goal. You want to get that negative 2 up here. So let's go ahead and add them up. 1 minus 24 is negative 23. Negative 1 plus 24 is positive 23. 2 minus 12 is negative 10. And we're just going to keep going here. Feel free to pause the video if you have to. But you're just adding these up. Each time you're just adding these up. Okay. And then again, you wanted the one that added up to negative 2. So we look. That's not negative 2, that's not negative 2, not negative 2, not negative 2, not negative 2. Keep going, keep going, keep going, until finally you realize, hey, I found the one that has negative 2. You do not have to write every factor. You can stop as soon as you find this. So if you noticed at the very, very beginning that 4 times negative 6 equals 24, I'm sorry, negative 24, and add it up to that, you're good. Don't even worry about moving on. All right? So we'll just go ahead and use these factors. So 4 and negative 6. What you're going to do now is you're going to take your problem and you're going to rewrite it. Okay, so I need you to rewrite your original equation. So remember, our original equation was 8x squared minus 2x minus 3. So we're going to write out the first term, 8x squared, and the very last term, minus 3. But then you're going to leave this big blank spot in the middle. Because what we're going to do is we're going to use the factors that we just found. You told me the factors that we need are 4 and negative 6. 4 and negative 6, I'm so sorry. So if these are the factors that you need, you're going to replace your middle term with this. So we'll write them in any order. You could write this as negative 6x plus 4, or 4x minus 6x. And I'm going to write it in that way. So I'm going to write plus 4x minus 6x. The only reason I wrote them this way is A, because I'm going to like it more this way, and B, because that's the order I wrote them in up here. So now that we've rewritten this, the reason we rewrote this is because 4x minus 6x is negative 2x. It's the same thing. We haven't really changed the problem. We just made it a little bit longer. So in order to simplify, in order to factor, we actually had to de-simplify. We had to make the problem a little bit more complex, a little uglier. Okay? Now that we're here, we're going to go ahead and start factoring by grouping. Alright? Go ahead and pair up your terms, the first 2 terms, and then the second 2 terms. However you do that, it just has to be the first 2 terms and the second 2 terms. So, 1, 2 terms, and then 1, 2 terms. Again, 2 and 2. Make sure it's not 1 and 3, not 3 and 1. It's 2 and 2. And then we're just going to factor out our greatest common factors here. To factor out greatest common factor, you have to take a look, and you have to say, okay, 8 and 4. What is the biggest number that goes into both 8 and 4? That would be 4. And then you have to look at your x's, so x squared and x. What is the greatest factor that goes into both x and x squared? You have to pull out the variable with the lower degree, or the lower exponent. So this is x to the second, that's x to the first. X to the first has a lower degree. You do not have to write that little 1. I just did it for examples purposes. Since we've dealt with all the numbers and letters, let's go ahead and find out what goes back in our parentheses. To find out what goes back in your parentheses, you just have to take each of these terms and divide by your common factor. So 8x squared divided by 4x is 2x, and then 4x divided by 4x, the same thing divided by itself, is just 1. You're going to do the same thing for the second parentheses. So between negative 6 and negative 3, their greatest common factor is going to be negative 3. Or rather, 3 is their greatest common factor, but I'm going to pull out the negative because I already noticed the negative signs. If you didn't notice this, you could actually push it off until the end. So let's go ahead and pretend we didn't notice. Let's pretend our greatest common factor we think is 3. That's fine. So keep this a positive, don't even worry about it. And then you're going to go ahead and notice. Sorry, I had to scratch that out. So we'll divide. Negative 6x divided by 3 is negative 2x. And then negative 3 divided by 3 is negative 1. You'll notice that this and this are not the same, but they're very close. That's a 2x and a 1. That's a negative 2x and a negative 1. To make that a negative, or I'm sorry, to change a negative to a positive, let's just pull out a negative sign. Now both of these are positive. Now you'll notice these are exactly the same. I was supposed to write this in blue. I messed up my color coding. Anyway, these 2x plus 1s are the same, so you're going to write them once. Alright, so we're going to group them together in just one parentheses. After that, you're going to group everything else together. Everything else. So, we already grouped our 2x plus 1s, but you still have a 4x, and you still have a minus 3. At this point, you'd have factored your problem, and you would be done. This is all you have to do. Alright, so again, let's go over factoring by grouping really quickly. Really quickly. Multiply a times c, you'll get a number. Factor that number until they add up to your b term. So they add up to your b term. After that, rewrite your problem, replacing the b term with your new factors. Then, write parentheses around the first two and the second two. Factor out your greatest common factor of each. And after you've done that, you'll notice that these two are the same. If they are not the same, you screwed up and you didn't factor out the greatest common factor, but if they are the same, then you're good. Group them into one, and then write whatever else you have in the other parentheses. Once you've done that, you have covered everything for this test on Monday. So, hopefully all of that makes sense. Hopefully you can stop, record, pause, slow down, do whatever you need to do. I hope it all goes well. I'm going to go ahead and put each and every page on the screen for just a moment so that you have that. Feel free to go back to the beginning of the video. Alright, so let's go ahead, page 1. Okay, So page 1, simplifying radicals. If we go down a little lower, feel free to pause. Simplifying radicals through addition and subtraction. And there's the other part of it. Okay. And then after simplifying radicals through addition and subtraction, we had multiplying and dividing radicals. So that's multiplying and dividing radicals. And then we have factoring difference of perfect squares. There are your two conditions. And there's your example with the two conditions right above it. Factoring perfect square trinomials, your two conditions, and then your two conditions with the example below it. After that, factoring by grouping, and this entire example is kind of big, so I'm not going to get it all on one screen, but that's okay. You found your last one there, and then there's the working it out. Those are all the topics that are going to be on your test. You should be perfectly fine if you can handle those. Best of luck, study hard, and have a great weekend. Bye, guys.